Welcome back to the Deep Dive. Today, we're going to strip away probably the single most comforting lie you tell yourself every day.
That's a strong start.
Well, it is. It's a lie you repeat every morning when you look in the mirror, every time you sign a contract, and, every time you order coffee. It is the lie that you are, or you.
It feels a bit aggressive to call it a lie right out of the gate, but biologically speaking, you aren't wrong. We are absolutely tackling the illusion of control.
Right. And I want to set the stage here because I think most of us, myself included, we operate on what you could call the CEO model of consciousness.
The CEO model, yeah.
I feel like there's a little mini-me sitting right behind my eyes. I'm the pilot. I'm the captain of the ship. I look out the windows. I see the world. I process the data, and then I pull the levers. I decide to speak. I decide to move my hand.
It's the intuitive sense of agency. It's the user interface for being a person. It feels unified. It feels singular.
Exactly. But looking at the stack of research we have today, from neuroscientists like David Eagleman, Michael Gazzaniga, all these people, that feeling of unity is, well, it's physically impossible. I was just looking at the sheer numbers. The brain has nearly 90 billion neurons.
And that's just the cell count. Those neurons are organized into, over 100 distinct specialized regions. You have the visual cortex back here processing light, the amygdala handling threat.
The cerebellum coordinating movement, the brainstem just keeping your heart beating without you even thinking about it.
It's a sprawling, noisy, chaotic factory floor.
And yet I don't feel like a factory. I don't hear the noise. I don't feel the 90 billion workers arguing over things. I feel like the boss.
And that is the central mystery we are diving into today. How does a squabbling committee of 90 billion cells create this incredibly convincing illusion of a single eye?
And more
importantly, if that eye is just an illusion, who is actually driving the bus? Because the data we're going to look at suggests that the CEO is often the last one to know what's even happening in the company.
It's a genuinely terrifying thought that the conscious me is just a figurehead, a puppet monarch.
Well, let's find out. Let's really dig in. We're going to look at what happens when that CEO goes on vacation. We're going to explore sleepwalking, the void of anesthesia, what happens when you literally cut the brain in two.
And the hidden biological thermostats that control our morality. So let's unpack this. And I want to start with a phenomenon that I think most people just dismiss as a quirk of sleep,
Right.
But when you actually look at the neuroscience, it's deeply, deeply disturbing. I'm talking about sleepwalking.
Somnambulism. It's the perfect entry point because it acts as a kind of dissociation test for the self. It really separates the doer from the dreamer.
In the source material, there's this case study from Dr. Emmanuel During, who's a sleep disorder specialist at Stanford. And he tells this story about a patient that honestly sounds like something out of a horror movie.
It's not your average case.
No, this isn't just a guy getting up and stumbling into a wall. This is something else.
This is complex motor behavior.
Exactly. So this patient gets out of bed in the middle of the night. He is fast asleep. He walks to his kitchen, finds his painting supplies, which, that alone implies he has to locate them. Maybe open a cabinet.
Uncap the paints, find a brush.
Yes. And he proceeds to paint a perfect triangle on the kitchen wall.
A perfect geometric shape, not just a smudge.
And then he cleans up, or at least puts the brush down and goes back to bed. The next morning he wakes up, walks into the kitchen to make coffee, sees this triangle, and he just freaks out.
Of course he does.
He starts laughing, but it's that nervous laughter of just total, utter confusion. He's asking his family, how the heck did I do this? He has zero memory of it. He didn't plan it. He didn't decide to do it.
And this is what Dr. During calls a glitch in the system. But it's an incredibly revealing glitch. If you just stop and think about what is required to paint a triangle...
It's not simple at all.
Not at all. You need depth perception. You need fine motor control in your fingers. You need balance to stand upright. You need spatial awareness to even know where the wall is.
And normally, we take credit for all of that.
Yeah.
If I paint a picture, I say, I painted this. But here, the eye was completely absent.
Which forces us to look at the brain scans. When you hook a sleepwalker up to an EEG, you see something that, it shouldn't really be possible. We usually think of sleep as a global state. Either the whole brain is asleep or the whole brain is awake.
Right, like a light switch. It's on or it's off.
But the EEG shows what they call a split state. The brain is in deep, slow-wave sleep, specifically NREM stage 3, which is the deepest, most restorative phase. The background rhythm of the brain is just these big, high-amplitude, slow-rolling delta waves.
Okay, so the background hum is definitely deep sleep.
Exactly. But then suddenly, superimposed on that sleep rhythm, you see these massive spikes of activation in very specific regions. The motor cortex, that strip across the top of the brain that controls your muscles, it just lights up.
Okay.
The visual cortex in the back of the brain processing what the open eyes are seeing, it lights up too. The cingulate cortex, which handles some basic emotion and monitoring, that might even flicker on.
So the factory floor is fully operational. The workers are on the assembly line. They're building the car. So who's missing? Who's not there?
The dorsolateral prefrontal cortex.
CEO.
The CEO. The part of your brain right behind your forehead.
Yeah.
This is the region responsible for executive function, for self-reflection, impulse control, and this is crucial, autobiographical memory. In a sleepwalker, that part of the brain is cold. It is electrically silent.
Wow. So this is really the first major crack in that CEO myth. It proves that consciousness and competence are not the same thing.
Not at all.
You can be highly competent, you can navigate a room, paint a wall, in some tragic cases even drive a car all without being conscious.
Exactly. It suggests that the self is almost an add-on. It's a luxury feature. The base model of the human can function surprisingly well without it. The neuroscientist Daniela Schiller points this out. Things like sensory integration and motor execution are largely automated processes. They don't need you to be running.
That is just... It's so humbling. It's like finding out your car can drive itself, and that steering wheel you've been holding onto for 30 years is actually just a plastic toy glued to the dashboard.
It is a bit like that, yeah. The car allows you to think you're steering, but the second you fall asleep, the lane assist and the cruise control take over, and, they do a pretty decent job on their own.
But there's a key distinction here. Sleepwalking is a glitch where some lights are on and some are off. I want to move to a state where we deliberately turn all the lights off. I want to talk about anesthesia.
Anesthesia. It's a fascinating counterpoint. In sleepwalking, the brain is dissociated. Parts are awake, parts are asleep. With general anesthesia, we're trying to shut down the entire system so we can perform surgery.
And anyone who has been under knows the difference. I've had surgery a couple of times. Sleep. Sleep feels like a process. You drift, you dream, you feel time pass. Anesthesia is a splice in the film reel.
That's a great way to put it.
You're there, counting backwards from 10, 9,
Yeah.
and then instantly you are waking up in the recovery room. There's no blackness. It's just nothingness.
That nothingness is exactly what Dr. Emery Brown studies. He's an anesthesiologist at Harvard and MIT, and he spends his time looking at the brain's electrical signals to define that exact moment when you leave the building.
And he uses this great analogy in the research about brainwaves. He compares the awake brain to a cocktail party.
It's the perfect metaphor for neural synchrony. When you're awake and conscious, if we look at your EEG, we see these high-frequency, low-amplitude waves. It looks really jagged and chaotic.
Right.
And that's because you have millions of different local conversations happening all at once. The visual cortex is talking to the parietal lobe. The hippocampus is whispering to the frontal cortex. It's a loud, diverse buzzing room.
So the chaos is the consciousness. The complexity of it all is the experience.
Right. Now, when the anesthesia drug, let's say it's propofol, hits the system, it changes that rhythm. It doesn't just quiet the room. It does something much stranger. It forces everyone to chant in unison.
Chants.
Yeah. The brain waves slow down massively. They become these huge, rhythmic, low-frequency oscillations. So instead of a million complex conversations, every neuron starts firing together, then resting together. Firing. Resting.
And Dr. Brown calls this the hum.
It's a hum that completely drowns out any useful information. Think about it. If everyone at that cocktail party starts chanting OM at the exact same time, you can no longer have a conversation. You can't exchange information.
And this brings us to the actual mechanism. Why does that chanting stop me from feeling pain or even knowing who I am? It has to do with the thalamus.
The thalamus. It's these two walnut-sized structures deep in the center of your brain. For a long time, we just thought of it as a simple relay station, like an old-school switchboard operator that takes signals from your eyes and ears and just sends them up to the cortex.
But it's more than that.
Oh, it's much more. It's a feedback loop. The thalamus sends signals to the cortex, and then the cortex sends signals right back down to the thalamus. That constant reverberation, that back-and-forth loop, that's what binds all your sensory inputs into a single, unified moment of consciousness.
So I am the loop.
You are the loop. Anesthesia works by hyperpolarizing the neurons in both the thalamus and the cortex, which effectively severs that connection.
It unplugs the router?
It unplugs the router. The thalamus shuts down. Your visual cortex might still be physically capable of firing, but it can't talk to the rest of the brain. It's shouting into a void.
And without communication, there is no unity.
And without unity, there is no you. This is the really crucial takeaway from all the anesthesia research. Consciousness is not a thing you can find in a specific neuron. You can't put a slice of brain under a microscope and find the soul cell. Consciousness is the communication between the regions. When that conversation stops, the self just evaporates.
It really just reinforces the fragility of it all.
Yeah.
We're just a temporary pattern of energy. And if you disrupt the timing of that pattern, it dissolves.
It's extremely fragile. And, speaking of disrupting timing and connection, what happens if we don't shut the whole machine down, but we cut the main cable connecting the left side to the right side?
This is the split brain research. This is the stuff that genuinely keeps me up at night.
It is probably the most mind-bending data that we have in all of neuroscience.
So for everyone listening, let's just quickly establish the anatomy. We all have two hemispheres in our brain, left and right, and they are connected by this superhighway of nerve fibers called the corpus callosum.
It's about 200 million axons. It's a massive, massive bridge.
And back in the mid-20th century, doctors discovered that in patients with severe epilepsy, seizures were actually traveling across this bridge. They'd start on one side and just set fire to the other. So to save the patients, they performed a callosotomy. They surgically cut the bridge.
Just severed the connection completely. The two halves of the brain were now physically isolated, living inside the same skull.
And this gave researchers like Roger Sperry and Michael Gazzaniga this unbelievable opportunity. They could basically interview the two halves of a person's brain separately.
And this is where the illusion of control really just starts to crumble into dust.
Yeah. The outline mentions an experiment that the host of the documentary, Heather Berlin, she tried this herself to demonstrate how hard dual processing is in a normal brain.
Right.
She tried to draw a circle with her left hand and a square with her right hand at the same time.
Have you ever tried to do that?
I have, yes. It's completely impossible. You end up drawing two rounded squares or two square circles. Your hands just want to do the same thing.
That's because of the corpus callosum. The motor plans from your left hemisphere and your right hemisphere are crossing that bridge and interfering with each other. They're literally fighting for control of the steering wheel.
And this is the kicker. A split brain patient can do this perfectly.
Flawlessly. The left hand draws a perfect circle. The right hand draws a perfect square. There's zero hesitation, zero interference.
Because the two sides aren't talking to each other.
Because they are two separate agents. The left hemisphere has its task, the right hemisphere has its task, and they are just executing them independently, in parallel.
This implies that in a split brain patient, there are two people in there. Two separate streams of consciousness.
That is the staggering implication. But it gets even darker when we look at how these two agents interact, or more accurately, how one of them completely dominates the other. We have to talk about the Texas experiment with the patient known as Joe.
This is the smoking gun. Can you walk us through this carefully? Because the details here, they really matter.
Okay. So we know that for most people, the left hemisphere is dominant for language. It speaks. It's the narrator. It's the one doing the talking right now.
The left brain is the loudmouth.
Yes. The right hemisphere, on the other hand, is mostly silent. It can understand language, it's visually superior, it's very emotional, but it cannot produce speech.
So, Dr. Gazzaniga sits Joe down. Joe has a split brain. Gazzaniga flashes the word Texas on a screen. But, and this is key, he positions it so that it only appears in Joe's left visual field.
And because of the cross-wiring of the brain, everything in your left visual field goes to your right hemisphere. So Joe's silent, non-verbal right brain clearly sees the word Texas.
But the left brain, the one that controls the mouth, the talker, it literally saw nothing.
Correct. So Gazzaniga asks Joe, what did you see? And Joe's left brain answers, completely honestly, I didn't see anything.
But the right brain is sitting there essentially screaming, I saw it, it said Texas, but it has no voice.
Exactly. So Gazzaniga brilliantly changes the mode of communication. He says to Joe, okay, pick up this pen with your left hand, which, remember, is controlled by the right brain, and draw what you saw.
And Joe's left hand immediately draws the state of Texas.
He draws the map. He even puts a star in the middle for Austin. It's unmistakable.
Yeah. Okay, that alone is incredible. It proves there is knowledge inside his head that his conscious self, the speaker, doesn't have access to. But what happens next is the part that truly disturbs me.
This is the twist. Gazzaniga looks at the drawing and he asks Joe, very simply, why did you draw that?
Now, rationally, the only correct answer for Joe should be, I have no idea, my hand just moved on its own.
He should, but he doesn't. In a similar test, they flashed Texas to his right brain, and his left hand drew a cowboy hat. When Gazzaniga asked why, Joe's left brain saw the drawing of the hat on the paper. The left brain didn't know why the hat was there.
But I had to explain it.
It had to. And instantly, without missing a beat, Joe just says, oh, I drew a hat because we're in Texas and I love Western movies.
You lie.
He confabulated. He made up a plausible story to explain the evidence in front of him.
But he didn't know he was lying, did he? In his mind, he believed that's why he drew it.
That's the scariest part. He fully believed his own story. His left brain was presented with a mystery. Why is there a picture of a cowboy hat here? And instead of admitting ignorance, its job is to invent a cause. I must have wanted to draw a hat.
Gazzaniga calls this specific module the interpreter.
The interpreter. He believes it's a dedicated system in the left hemisphere that is constantly monitoring our behavior, our emotions, the environment, and it's stitching it all together into a coherent narrative that makes sense.
It's a storyteller.
A storyteller whose primary job is to make the world seem logical. If you do something for an unconscious reason, the interpreter will retroactively invent a conscious reason to explain it away.
See, this is the point where I can look at Joe and say, okay, that's fascinating, a little sad, but he has a brain injury. But Gazzaniga's point, and your point, is that we have an interpreter too.
We absolutely do. The only difference between us and Joe is that our hemispheres are connected, so the interpreter usually gets the correct information to spin its story. But not always.
So if I snap at my spouse because I'm hungry, low blood sugar, a purely biological state.
Right.
My interpreter doesn't say, beep boop, glucose levels are low.
No, your interpreter says, I snapped at him because he left the dishes in the sink again and he never listens. It finds a logical, narrative reason for a purely biological impulse.
That means we are constantly rewriting our own history. We're constantly spinning the events of our own lives to make ourselves look like rational, intentional actors.
We are the ultimate spin doctors for our own behavior. We think we're the chess master, carefully planning each move. But a lot of the time, we're just the sports commentator, confidently explaining the moves after they've already happened. Oh, a brilliant move with the rook. No, maybe he just had a muscle twitch.
It calls into question the veracity of our own internal monologue. If I ask myself, why did I choose this career? Or why did I fall in love with this person? The answer I give myself might just be a convenient story cooked up by the interpreter to make sense of a gut feeling.
It's very, very likely that the reasons we give ourselves are post hoc rationalizations for things that were decided milliseconds or even years earlier by unconscious processes.
Well, speaking of gut feelings, let's go deeper into that. We've talked about the interpreter making sense of our actions, but what's driving the actual behavior in the first place? If the CEO is just the PR guy, who's the mechanic down in the engine room?
This brings us to the biology of emotion and morality. We like to think our moral compass is this high-level spiritual or intellectual thing. But the research suggests it's basically just a thermostat.
A biological thermostat. This comes from the work of Dr. Luke Chang on something he calls guilt aversion.
Right. Chang uses a classic experiment from behavioral economics called the trust game. It's simple. I give you $10, you can choose to invest it, and it automatically triples to $30. But then you have a choice to make.
Do you keep all $30 for yourself, which is the greedy option?
Or do you return half, $15, back to me, the generous option?
And logically, if I'm a purely rational, selfish actor, I should keep all the money. I'll never see you again. There are no consequences. Why share?
Exactly. And yet, the vast majority of people across cultures, they return the money.
Because we're nice people.
Because we are fundamentally wired to avoid the feeling of guilt. Chang put people in brain scanners while they played this game, and he found this specific circuit that acts exactly like an HVAC system for our behavior.
Okay, let's break down the HVAC components. You said there's a thermometer first.
The thermometer is the insula. This is a region of the brain tucked deep in the folds of the cortex. The insula is responsible for interoception. That's sensing the internal state of your body. It's what feels pain, what feels nausea, what feels disgust.
So when I even think about stealing that money from you.
The insula lights up. It runs a simulation of how bad that would feel. It creates that pit in your stomach, that squirmy feeling. It's the alarm bell saying, temperature rising, this feels bad.
So guilt isn't some abstract philosophical concept. It's a literal physical sensation of disgust that's being generated by the insula.
Precisely. And once the thermometer's alarm goes off, the thermostat kicks in.
And the thermostat is our old friend, the prefrontal cortex.
The CEO returns. But notice the CEO isn't deciding in a vacuum here. It is reacting to the signal from the insula. The prefrontal cortex reads that distress signal and says, whoa, it's getting too hot in here. We need to cool this system down. And so it makes the decision to return the money.
Just to make the bad feeling go away.
Right. You aren't being generous primarily to be a saint. You're being generous to return your own biological system to homeostasis. You're doing it to stop the insula from screaming at you.
It's a regulatory loop. So, what happens if the thermostat breaks? What happens if you have the urge, the feeling, but no regulator to control it?
And that brings us, inevitably, to Phineas Gage. You simply cannot have a serious neuroscience discussion without paying homage to Phineas.
The man, the myth, the legend with the tamping iron. For the maybe 3 people listening who haven't heard this story, give us the gritty details.
It's 1848, Cavendish, Vermont. Phineas Gage is a railroad foreman. He's 25 years old. By all accounts, a model citizen. Smart, responsible, efficient, well-liked by his men.
The CEO is working perfectly.
Flawlessly. And he's packing explosive powder into a hole with a 13-pound iron tamping rod. It's basically a metal javelin. A spark ignites the powder by accident. The rod becomes a missile.
And the trajectory is just horrific.
It enters just under his left cheekbone, passes directly behind his left eye, and completely destroys the orbitofrontal cortex, a key part of the prefrontal cortex, and then exits out the top of his skull, landing about 80 feet away.
And somehow, he doesn't die. He just stands up.
He acts as if almost nothing happened. He is conscious. He walks to the ox cart. He's talking to the doctor when he arrives. His first words are, "Here is business enough for you."
But while the man survived, Phineas didn't.
Exactly. The man who came back from that injury was not the Phineas Gage his friends and family knew. They said Gage was no longer Gage. He became fitful, irreverent, grossly profane. He couldn't stick to a plan. He'd get into fights. He lost all his social graces.
He lost the thermostat.
He lost those specific inhibitory circuits in his prefrontal cortex. He probably still had the insula. He likely still felt all the urges and emotions, but he had absolutely no way to regulate them. He became a slave to his immediate impulses.
This is so profound because it physically locates personality in a piece of tissue. We have this idea that our character is this immutable soul. But if I can change your character from gentleman to profane drifter just by damaging a cubic inch of meat behind your forehead, what does that say about the self?
It says the self is entirely dependent on the hardware. If the hardware changes, the user changes. It's that simple.
So we're regulated by these biological thermostats. But let's zoom out for a second. The thermostat is set to a certain temperature, right? Who sets that temperature? Why do I feel guilt about stealing, but maybe someone from a different culture or from 500 years ago wouldn't feel it as strongly?
Now we're getting to the question of programming, the wiring of the brain. And some of that wiring definitely comes from our environment, our social norms, our upbringing, peer pressure. But some of it comes from before we were even born.
This is the section on epigenetics. And I have to admit, when I first started reading about this, I was really skeptical. It sounds a lot like Lamarckian evolution, that old idea that if a giraffe stretches its neck its whole life, its baby will be born with a longer neck.
And you're right to be skeptical of that. We know that's not how it works. The DNA sequence, the actual letters A, C, T, G, that doesn't change because of your life experiences. However, the expression of those genes can change. This is the field of epigenetics. The best analogy is that your DNA is the script of a play. You can't change the words, but you can change the stage directions. You can add a note that says, shout this line or whisper this one. You can effectively skip a scene by silencing a gene.
So epigenetics is like the volume knob on our genes.
Exactly. And the really wild research by Dr. Bianca Jones-Marlin at Columbia University suggests that these volume settings can be passed down through generations.
She did this study with mice that feels incredibly cruel, but at the same time incredibly revealing.
It is. She took male mice and exposed them to the scent of almond. It's a chemical called acetophenone, a pleasant smell. But every single time they smelled it, she gave them a mild electric shock to their feet.
Classic Pavlovian conditioning. Smell almond, get shocked, feel fear.
Exactly. The mice learned to be terrified of the smell of almond. And when they looked at their brains, they saw a physical change. Their olfactory bulbs produce significantly more M71 receptors. Those are the specific cells that detect the almond scent. They became hypersensitive to the smell of the threat.
Okay, that makes sense. That's adaptation within a single lifetime. The mouse learned something new.
But then, those male mice were allowed to breed with females who had never been shocked. The offspring were then raised completely without their fathers. They never met them, they were never shocked themselves, they never even smelled almond.
And the babies, what happened?
The babies were born with the same hypersensitivity. They had more M71 receptors in their noses from birth. They were born with an innate fear of the smell of almond.
Wait a second. So the trauma of the father physically altered the brain structure of the son who never experienced the trauma.
Yes. Through a process called methylation, which happens in the sperm, the instruction to build more almond receptors was passed down. The memory of the trauma literally skipped the generation gap.
That's heavy. Because we aren't mice, but we are mammals.
And we see parallels in humans. Studies on the descendants of people who survived the Dutch hunger winter or the children of Holocaust survivors show altered cortisol levels and stress responses that mirror their parents.
So if I have a generalized anxiety, if I'm jumpy, or if I have a really strong gut feeling that a certain situation is dangerous for no reason I can explain,
It might not be your memory. It could be a ghost in your machine. It could be a biological adaptation to a threat that your great-grandfather faced.
it complicates this illusion of control even further. Not only is my interpreter lying to me and my thermostat regulating me, but my entire GPS system might have been programmed by an ancestor I never even met.
It creates a fascinating and very deep philosophical problem. If your brain is wired by your ancestors and your choices are regulated by your biology, where is there any room for free will?
That is the ultimate question, isn't it? The illusion of agency. Do we actually make choices, or do we just experience them after the fact?
To test this, we have to look really closely at the timeline of a choice. When exactly does a decision happen in the brain?
The outline brings up a neuroscientist who is also a magician, a guy named Uri Maus. And he uses magic to demonstrate how easily our feeling of choice can be manipulated.
Magic is basically just applied cognitive science. Maus does a trick where he'll ask a participant to pick a card or a seat in a room, and the participant feels they are picking completely freely. I'll sit in the chair on the left.
Right.
But Maus has used all these subtle cues, priming, positioning, the specific language he uses to actually force that choice without them realizing it.
But the subject still says, I chose the left chair. They will defend their own agency.
Because the feeling of agency is a totally separate brain process from the reality of agency. We can feel in control even when we're being completely puppeteered.
Okay, but let's get more rigorous than card tricks.
Uh,
The TMS finger experiment is the one that really unsettles me. This moves from magic into pure neural timing.
This is a classic setup in neuroscience. You have a participant, let's call him Tomas. He's hooked up to a TMS machine, that's transcranial magnetic stimulation. It's a magnetic coil they place against his scalp that can fire a pulse and physically stimulate the motor cortex.
So they can literally zap his brain and make his finger twitch against his will.
Yes, they can treat him like a puppet. But at the same time, they can also read his brain's own signals with an EEG. Now, we know from previous research, the famous Libet experiments, that the brain prepares to move well before you're consciously aware of it.
Right, the readiness potential.
The readiness potential. It's a signal that fires about 300 to 500 milliseconds before you have the thought, okay, I'm going to move my finger now.
Half a second. That's an eternity in brain time.
It's forever. So in this experiment, they asked Tomas to just move his finger whenever he feels the urge. But sometimes they secretly use the TMS to force the finger to move, and they try to trick him. They'll fire the TMS pulse right around the time his brain is naturally prepping to move on its own, within that tiny 50 millisecond window of ambiguity.
They're trying to intercept the command.
And then they ask him, did you move your finger that time, or did the machine make you do it? And if the timing is just right, Tomas says, I did it.
He takes credit for the magnet's action.
He claims agency over an involuntary movement simply because it matched his brain's internal state of getting ready to move. His interpreter saw the finger move, it felt a vague readiness signal bubbling up, and it stamped the action. Approved by CEO.
This suggests that our whole sense of agency is retrospective. We don't issue commands from on high, we receive reports from the field.
That's the retrospective agency theory. The action happens unconsciously driven by the 90 billion neurons, the ancestral ghosts, the biological thermostat. The action occurs. Then, milliseconds later, the conscious mind gets the feedback report. Action complete.
And to avoid feeling like a robot.
To avoid feeling like a robot, the conscious mind says, oh yes, I willed that to happen.
It's like a king who sees his army already marching off to war and quickly writes a decree ordering them to invade, just so he looks like he's still in charge.
That is the perfect analogy.
Yeah.
The king is frantically signing decrees for things that have already happened just to maintain the illusion of control.
This is pretty bleak. We spent the last 45 minutes just dismantling the self. We are sleepwalkers, we're split personalities, we are puppets of our ancestors, and we are delusional kings taking credit for the army's work. Is there any upside to this?
There is a massive upside, a huge one, and it requires a total reframing of what it even means to be good at something.
Okay, save us. Please give us the silver lining.
The silver lining is this. If the conscious CEO is slow, delusional, and often a bottleneck, maybe we are much better off without him.
This brings us to the neuroscience of flow.
Exactly. This is the brilliant work of Dr. Charles Limb. He's a surgeon, a neuroscientist, and also a jazz musician. And he wanted to know what the brain looks like during pure, unadulterated creativity.
So he studied jazz improvisation and freestyle rappers.
Right. He put these incredible freestyle rappers like Chris Emdin into an fMRI scanner. Now, rapping in an MRI is incredibly difficult. It's loud, it's claustrophobic, but he had them do two tasks. First, rap a memorized set of lyrics, something simple they knew by heart, like Mary Had a Little Lamb.
Okay, a rehearsed task.
And second, freestyle, improvise, make it up on the spot, rhyming, keeping the beat, being truly creative.
And what happened in the brain? What was the difference?
When they switched from the memorized rap to freestyle, when they entered that flow state, the brain didn't light up like a Christmas tree. It actually got darker in a specific area. The dorsolateral prefrontal cortex deactivated.
The CEO went on to lunch.
The part of the brain responsible for self-monitoring, for criticism, for planning, for worrying, am I doing this right? Is this good? It's shut down. The scientific term is hypofrontality.
So to perform at the absolute highest level, to be a creative genius, essentially, you have to turn off the conscious self.
You have to get out of your own way. We see this in sports all the time. I call it the free throw effect.
Oh, the yips.
Yeah.
Choking under pressure.
The yips. If a pro basketball player stands at the free throw line and starts thinking about it, okay, bend the knees 45 degrees, flick the wrist, check the backboard, they miss, they choke. Because the slow, clunky, conscious CEO is trying to manually override a highly skilled, highly trained, automated system.
The 90 billion neurons already know how to throw the ball. They've done it 1,000 times. The CEO is just getting in the way and messing it up.
Exactly. The unconscious, the whole factory floor, is incredibly capable. It's faster, it's more creative, and it's far more precise than the little I we identify with.
So the illusion of control isn't a tragedy after all. It's a strategy.
It's a liberation. If you can truly accept that you, the conscious narrator, aren't the one doing all the heavy lifting, you can actually relax. You can trust the machine. You can let the music play itself.
That is actually really comforting. It changes the entire goal from how do I control everything to how do I create the right conditions for my brain to do its amazing thing.
Precisely. You aren't the driver. You're the gardener. You till the soil, you provide the water, you pull the weeds, but you don't reach into the plant and manually pull the stem upwards to make it grow. The plant already knows how to grow. You just create the environment for it to thrive.
I love that. So let's try to synthesize this monster of a deep dive. We have covered a lot of ground here.
We really have. We've gone from the sleepwalker's triangle to the split brains cowboy hat, from the biological thermostat of guilt to the ghosts of our grandfathers, and finally to the freestyle rapper in the MRI machine.
And the central question throughout was, who is driving the bus?
And the answer seems to be, the bus is being driven by a committee.
A very crowded, very noisy committee.
A committee of 90 billion neurons, ancient evolutionary drives, inherited genetic memories, and constant social programming. And sitting at the very front of the bus, holding a plastic toy steering wheel, is the conscious self, bravely shouting out directions that nobody is really listening to.
But, and I think this is a key point, that guy with the toy steering wheel is still important.
Oh, he's crucial. The illusion of unity, the story he tells, is what allows us to function in society. We need to feel like agents, to sign contracts, to fall in love, to take responsibility for our actions.
It's the user interface. I don't need to see the millions of lines of code. I just need to be able to click the icon on the screen.
Exactly. Just don't ever confuse the icon for the computer itself.
That leads me to a final thought I want to leave our listeners with. It's a bit of a provocation.
Go for it.
If the conscious you is largely a retrospective storyteller, If you are basically the PR agent who holds a press conference to explain the actions of the unconscious factory,
Hmm.
how does that change the way you view your mistakes?
It creates compassion, doesn't it?
Right. If I snap at my kids or I fail a test or I eat the cake, I said I wouldn't. Maybe it wasn't a moral failure of my soul. Maybe it was a regulatory failure.
The thermostat was set wrong, the glucose was low, the ancestral ghost was scared.
It allows you to debug the system rather than shaming the self. You can say, okay, the machine malfunctioned. Why? Was I tired? Was I stressed? Instead of just concluding, I'm a bad person.
And conversely, when you succeed, when you enter that flow state and you produce something amazing, something you didn't even know you were capable of, maybe take a second to thank the silent majority inside your skull.
Thank you, Factory. Good work today.
Exactly.
Yeah.
I don't know how you did that, but keep it up.
It's a partnership. It really is. Thank
Well,
you for taking this journey with us. It's been a mind-bending one.
it's always a pleasure to dissolve the ego with you.
We'll see you on the next deep dive. Until then, try to enjoy the ride, even if you aren't the one driving.